Hello. In this video, we will introduce Python development using primarily Anaconda. We will also touch on the Python interpreter shell. There are also tools called Fiddles, and some of them work and some of them don't. I've linked to one in this slideshow that we can take a peek at. Our tool of development primarily in this course is JupyterLab, and I access JupyterLab through Anaconda. So that's what I will go ahead and talk about. I'm also a big fan of using Eclipse as a development environment. It supports Python pretty well, and it has some distinct advantages over JupyterLab, but JupyterLab has some advantages over Eclipse. And I won't talk too much about Eclipse today. As we go through the term, I will talk more about it just to give you a more rounded background. We use the term REPL, R-E-P-L, read, evaluate, print, and loop, to describe a type of environment. And Python, as far as the interpreter shell goes, conforms to this style. It's okay for simple, very simple things, for testing out a little bit of code, very little bit of code to see what it does, a little bit of experimentation. It's not something you want to spend your whole day in, but it's nice to be exposed to it and to know that it exists. I have it installed already right there. I have 3.9. If you've installed it recently, you'll have a similar version. I think 4 is either out or on the horizon. I won't be using 4 in this class. I'm not even sure if it's available myself. I don't keep up that closely. But it is being talked about, and I have read about it. I just don't know if it's available. And this is our Python interpreter shell. And that means that anything we type goes directly to the Python interpreter, instead of a command shell or a PowerShell like you might have seen in other classes or at work. When you press enter here, that line of code that you typed in goes to the interpreter. The interpreter interprets that line of code. If there's any output, it immediately appears on the screen in that window. This is read, evaluate, print, and loop. I sometimes say R for repeat. That's the REPL environment. If I close the window, then I lose all my work, and that makes it kind of awkward for anything of any significance. But there are ways to save parts of your work and kind of pick up where you left off, but I wouldn't recommend it, spending a lot of time here. You may have more interest in it than I do. You may find it to be a great thing. I find it to be a good tool for 1 or 2 lines of code. If I want to see, if I want to paste in some code from the outside, but even if you find yourself pasting in code, the code kind of disappears in a hurry and you can't see more than 1 line at a time. Just not the best place to go to spend a lot of time trying to learn how to make an application of any significance. I'll leave it open. I might come back to it later. Here's a link to a fiddle that actually works. You're welcome to go there. And you can see that it's in some ways a little bit more effective than the REPL environment, because I can type in multiple lines of code and study them and edit them and then execute them all together, rather than typing in code 1 line at a time in the interpreter shell. I think you can save here. Again, I don't do a lot of things here that I would have any interest in keeping. It's just a temporary environment. Maybe I'm somewhere that I don't have a Python shell installed for whatever reason and I need to bring up a quick interpreter. This is a way to do that. I certainly would be very careful putting anything sensitive in here, API keys or credentials, because I'm sure they're getting scraped by whatever web server is at the other end. Our tool of choice then is Jupyter Lab. And at this point, if you haven't installed Anaconda, you should stop the video, go get a cup of coffee, install Anaconda. Anaconda will also bring down Python, the interpreter, and you'll get both. And then you can continue here. You will need Anaconda or Jupyter Lab to continue in the course. The only thing I do with Anaconda in this course, I'll start it up. The only thing I do with Anaconda is use the navigator to access Jupyter Lab. It's just my jumping off point to that utility. And it takes a moment to load. This is also free. I don't know if there's a Mac version. But while this is loading, I'll say that Jupyter Lab is an excellent prototyping tool. It lets us create things called cells and put code into these individual cells and then execute them at will. And we're building this execution environment of data. We're initializing variables and reading files. And then we can execute against that environment by running individual cells in a Jupyter Lab notebook. Much more flexibility and much more capability than the Fiddle or the REPL shell. Hopefully I have Anaconda going. There it is. Anaconda is up. The only thing I'm ever going to do here is go to Jupyter Lab. Now Jupyter Lab starts a little web server, and then you will see a tab of my browser that signs into that web server. And if you look up in the address bar, you'll see localhost. That's you. Okay, that's your machine. All right, and there's an assignment that you don't need to see. And you should end up with something like this. If you don't have this browser tool on the left, you can click this folder button to open that browser. I leave this open all the time because I go back and forth between a lot of files and I don't need as much screen space. You can shrink this in and out to a certain extent. If you don't like it there, you can close it. I just prefer having it there. There's also a browser-based version that doesn't need installation on your machine. So you can log into their web server with your browser and run Jupyter Lab programs and write Jupyter Lab code. I'm not going to do that. I don't think it's conducive to what we're trying to accomplish because you don't have total control over your work. I just think you're better off installing Anaconda and then jumping off into Jupyter Lab. So the first thing we'll do is write hello world, as we always do when we learn a new programming language. I'm going to flip back to Jupyter Lab again. And I have what's called a launcher open. And from the launcher, I'll create a new Jupyter Lab program. If the launcher isn't open, sometimes it gets closed. I'm trying to close it, and the one time I need it to close, it won't close. Anyway, if you do need a new launcher, you can see that under the File menu, you can select New Launcher. I don't have to do that because my launcher is locked in and it won't go away. And if you click Python 3 under the notebook category, you get an empty notebook. The notebook is a file on the disk, and the file extension is IPYNB, Interactive Python Notebook, IPYNB. Don't change that. This is not, strictly speaking, a text file. It's going to have some HTML in it and some markup and things. So from my perspective, one of the disadvantages of JupyterLab is because it does not store source code in a text format. That JupyterLab file is not interoperable with other Python tools like Eclipse or even the shell. So that to me is a big deal. It's not going to bother us too much this semester, but for the purposes of enterprise work, I think that interoperability between tools is important, and I don't see that here. Now, I understand why they gave it up for the sake of other compatibility of other features that they wanted to build into JupyterLab, so we'll live with it. It's fine. All right. When I created the new notebook file, it created an empty cell. You can see there's a little cell there outlined in blue. That's where I can start typing my code. Notice that I'm in my browser. So even though I'm saving files on my local file system, I'm still using my web browser to access the JupyterLab environment, which is both good and bad. It's good because it's convenient. Everyone has a browser. It's bad because I/O through a browser is easily overwhelmed. So if you start doing large amounts of I/O, even accidentally, you can cause a problem. And I have locked up my machine to the point where I had to reboot. I've really tied up the browser so badly, and whatever other subsystems JupyterLab uses, that I've had to reboot the machine. So doesn't make me feel really good about hitching my wagon to JupyterLab, but as a prototyping tool, it's effective. Once we've got our cell open, we can type in our command and lowercase, sorry, print hello world. That's Python code. If you go back to the interpreter that I still have open, you can see that I typed in almost the exact same line of code. I did them differently on purpose. In Python, a double quoted string is the same as a single quoted string. They are interchangeable. Not the same thing you'd expect because Java is different, C# is different, C++ is different, but in the world of Python, they are the same thing. Double quotes and single quotes are the same thing. And can I do it without the parentheses? Can't do it without the parentheses. So right away, there's your first introduction to a syntax error. I tried to print something. I'm calling the print function, and that requires parentheses around whatever I want to print. So a call to a function requires those parentheses. Let's see if it doesn't work here. Now, how do I run this? Okay, I broke it intentionally. It's not going to work, but I run it by clicking the little arrow there, and that little arrow executes the current cell. If there are 100 cells, it only executes the current cell. It ignores the other 99. There it is. There's my error. I realize I need to fix this. Easy enough to do. Now notice what happened. When I typed in that opening paren, I'll do this again, watch closely. The editor in JupyterLab tried to outsmart me, and it thought that since I typed in an opening paren that I was going to need a closing paren. But to my dismay, I already had a closing paren at the end of this cell, and therefore I'm left with an extra closing paren, and I've got a mess on my hands. I have to delete, excuse me, that closing paren, and that's just a, for lack of a better term, a feature of JupyterLab trying to autocomplete a statement when it's just not going to work in that situation. So you've got to be aware, and you've got to go in if necessary and delete that extra character. This should work now. There it goes. Hello world. I clicked on the run button, and it ran the current cell. It also pops up a new cell. I can type in more code if I like. And there are two ways to go. One is to type all of your code into one cell, hundreds and hundreds of lines, and that's fine, but it's not effective. A better way to organize your code is in multiple cells, and then you can run cells as necessary. What happens much of the time is we have a few cells at the top that we only run once. They might go out and acquire some data, and then we don't have to run that data acquisition logic more than once, so we're not bogging ourselves down with excessive computer time. And then once we've got the data in our operating environment in this notebook, we can run operations on that data by executing other cells strategically. That's a big advantage of JupyterLab. You can't do that in Eclipse. And you'll see me do that as we go along through the semester. Another thing I can do, and you'll notice I'm back on the slide now. I'm on slide 9. Another thing I can do is create what's called a markup cell. And that's a documentation tool that makes our little notebook file into more of a friendly or interesting user interface. So instead of just code with some comments interspersed, I can add some markup, I can put in some color and some different fonts and sizes and things like that. And people find that engaging. And when they're trying to learn a programming language, it's a little bit more of a visual variation than just code. And if I go back to JupyterLab again, I want to put in, I'll just put in the 3 pound signs just like you saw on the slide, and I'll show you what happens. At this point, if I try to run this, there's nothing to run. It's not Python code, or executable code anyway. But it's also not supposed to be code. It's supposed to be Markdown. When I change it to Markdown and I run it, now I get something that's a little more visually engaging and just meant to be a documentation tool. If I realize I didn't like the Markdown and I want to edit it again, I can just double click on that, and that will bring it back into edit mode. If I drop a couple of these pound signs, you'll see that the font changes. There we go. And I don't make extensive use of Markdown. I'm a old school guy where if I want comments in my code, I'll probably just put comments in my code rather than using this Markdown tool. But I do use it periodically, and if you take the time to build visually engaging Markdown cells, then it does make your notebook a little bit more interesting to deal with, but you don't have to. It doesn't affect functionality of the code at all. So I'm going to go back and take that out. And if you look at the slide, you'll notice that the Markdown in the slide is at the top, but my Markdown is in the second cell, but I'd like it back at the top, so all I have to do is drag it up, and that puts it back at the top. Sometimes you'll want to run every cell, and that is accomplished by clicking on the double arrow. But that has another effect as well. That restarts what we call the kernel, which is your operating environment, your sandbox, so to speak. If you have any variables created or data stored, then you will lose that. That starts from the very top and runs all the cells sequentially from top to bottom. And let me just show you one of the probably most powerful features of JupyterLab relative to other IDEs, other development environments. I will add just a couple more cells. Now I have 3 code cells, and I have 1 Markdown cell. And if I click the double arrow to restart the whole notebook, I get the output from each of those cells underneath the code. So again, it's easy to determine which cell produced which output. That's pretty neat. But what if I decide that this cell labeled 2 needs an exclamation point? Or 2 exclamation points. I'm feeling very friendly today. I can run this cell all by itself by clicking on the run button again. And without changing any impact that the first or the third cells might have had, in other words, if they created variables or whatever, I can run the cells out of sequence. And you can see the numbers here telling you the sequence in which I ran the cells. Let's go back up here and run this one again. It's labeled cell 1. Now watch what happens. Now it's 5. Now we're seeing that I ran 3, then I ran 4, then I ran 5 based on these index numbers next to the cells. It's very easy to get lost and confused if you're watching the Bengals out of one eye and you're writing Python code with the other eye. Sometimes you forget which cells you've executed and which order you've executed them in. And you got to keep an eye on these little index numbers to tell you what you've done to that point. So it's a blessing and a curse to be able to execute the cells in and out of order. Now, just as an aside, I'm not going to continue on with this line of thought, but if you are using the online version, you can download your code when you're finished. Since I don't use the online version, my code is stored locally, and I don't have to worry about this. One thing you're also going to want to do is rename this file, certainly if you're going to turn this in. And even if you're not going to turn it in, it's a bad idea to have files accumulating that don't have descriptive names. You can look over on the left of my screen and you can see I've already got a file called Untitled1 that I created 10 months ago. And that's not very helpful to me because in order to figure out what's in there, I'm going to have to go look at it. So right click on the tab, select rename, and you can call this Hello World or whatever valid operating system file name you'd like to use. And when you turn in your assignments, you will be naming things in a very specific way, so be careful about that. Rename. And the file now shows up in my browser window with a new name, and it also appears as the new name in the tab. If you'd like another tab, which is another notebook, a separate file, then you can go over to your File menu in JupyterLab and select New Launcher or just New Notebook. Either one works. You can also run a terminal window to do things in PowerShell, like install libraries and that, which we'll talk about later. So here's all the steps we've gone through already. We've installed Anaconda. We've created a new notebook. The notebook has the default name Untitled, or if you already had one called Untitled, it adds a 1 to that, and a 2 and a 3 and a 4. And then you can rename it or you can save it using a new name or the same name. So even though you're in the browser, there's a lot of functionality that is similar to using Microsoft Word or any text editor. Now you know where it is, and you can find it for submission in this class or to send to your friends or give away as a Christmas gift, because over here in the browser window, there's a file path for you. So all of my files right now are stored in this subfolder. And it's not the best navigation tool, but it is nice because you can click on any of these folders and it will take you there. So you can navigate through your file system by clicking on folders. And we did that. We demonstrated how to run. At this point, you should be moderately comfortable with the basic navigation of the tool. I encourage you to look at the tutorials, pick up a YouTube video, and develop some more skills. There are a lot of shortcut keys and neat things you can do. One thing that they emphasize in many of the tutorials are the hotkeys. Now you've seen me in this video using the run button and the restart button, and of course there's a save button. You've seen me switch between code and Markdown using this menu. However, there are hotkeys to do all those things. You will be much more efficient. You will get done faster if you learn the hotkeys. I don't use the hotkeys because you can't see me press them, and something would happen on the screen and you wouldn't know why it happened. So I use the menu because I want you to be able to see what I'm doing. But I strongly encourage you to learn to use the hotkeys. All right. My last word. There is a debugger that supposedly works in Anaconda, but I have not had any success getting it to work. I've tried several times, and I posted a message on Stack Overflow, and I've gotten no response. One of the biggest issues that I have with this tool is that I don't have a debugger. If I want to develop anything of any complexity, I need to be able to set breakpoints and look at the contents of variables. I'm kind of reduced to putting in print statements, and I really don't like to do that because it's 2022. Check local listings for the year in your area. So I feel like that is a big shortcoming of this tool, and I'm a little bit frustrated with it because I can't get the debugger to work. If any of you have any luck getting the debugger to work, I'm not asking you to try, it's not part of the course, but if it's something that you've had success with in the past, perhaps I'd be more than happy to hear from you, and maybe you could walk me through correcting the problems that I'm having. Here is the question I posted on SO. This was not my first attempt at the debugger. I got one upvote, I got no comments, I got no answers. And I don't know where to proceed from there. I have put in the time and effort, I just haven't had any success. But again, if you're someone out there in the class who's had experience with Anaconda, who knows someone who might be able to take a look at this and explain the problem, I would be very happy to hear about it because it would dramatically improve the capabilities of this tool to be able to use the debugger. With that, we will discontinue this video. We will end this video. Thank you very much.